My name is Mayank, and today we are going to talk about the light mystery. Is light a wave, a particle, or both? So, the story of light starts in 1700s when Newton proposed that the light is made up of particles, and he named that particles as corpuscles. Okay, corpuscles. You can see the spelling on your screen. Okay, he said that light is made up of particles and it behaves like a particle. Okay, but about 100 years later, in 1801, a scientist named Thomas Young proved that light is behaving like a wave, so it must be a wave. He proved this by his double slit experiments, very well known double slit experiment, in which he passed the light from the two slits and observed a wavy pattern on the screen, which he, like we can say it as an observer, he observed a wave pattern on the observer screen. You can see like this pattern was observed by um, Thomas Young in his experiment. Okay, so you can see that this this part, this part, this part, this part, and this part. All these projections are of particles of light that fall on the observer. Okay, but he said that if light is passed through two slits, so it must be creating a two slit pattern on the observer, like two straight slits pattern on the observer. But light does not create a two slit pattern on the observer. Instead, it created a wave like pattern in on the observer. Okay, this wave is called as transverse wave. You can search it on Google, or I will make a separate video on the topic waves. Okay, so this is an example of transverse wave. Okay, this is called as constructive interference of wave, and the blank part is known as destructive interference of wave. Okay, so yes, we can see it properly. Like, this is a constructive interference of wave, this blank part is a destructive interference of wave, and so on. Okay, so it repeats. See, destructive, constructive, destructive, constructive, destructive, constructive. So this type of pattern was observed by Thomas Young or during his double slit experiment. Okay, then again, about 100 years later, Einstein came with the idea of photoelectric effect. Einstein also won a Nobel Prize for his discovery of photoelectric effect. So now, what is photoelectric effect? Okay, photoelectric effect can be defined as when fall some particles of light on a metal surface, many electrons from the metal surface starts to come out. Like, we can understand this by a apple tree experiment. Okay, so suppose we have a apple tree. Okay, on which many apples are grown. Okay, now we want that apples. So what we will do, we will throw stones on the tree. Okay, so if we throw the stones on the tree, it means that we are throwing some energy on the tree so that the apple should get detached and fall on the ground. Similarly, when throw some light on the metal surface, the energy of light makes the electron from the metal surface to get detached. Okay, so this was the idea of Einstein, and this photoelectric effect is used in many things in day-to-day life. Like, we can say that auto opening doors, like where there are sensors, and when the sensors detect a person, the doors open automatically. So these automatic doors work on the photoelectric principle. Okay, but then scientists thought that if we increase the intensity of light, then more number of particle will come out. Okay, the scientists thought this, but when they performed experiment, the conclusion came as, if we increase the frequency of light, like intensity is a different thing and frequency is a different thing. Okay, intensity means making light more brighter. Okay, and frequency means we can say that frequency means throwing more number of particles of light on the metal surface. Okay, so scientists thought that increasing the intensity of light will result in more electrons detached from the metal surface. But after performing the experiment, scientists came to the conclusion that increasing the frequency of light means increasing the number of particles of thrown light on the metal surface results in more we can say more number of electrons coming out of a metal surface. Okay, so this was again another observation. Then Einstein, after this experiment was performed and proved that increasing the frequency of light will result in a more number of electrons coming out of the metal surface. Einstein said that the light must be made up of energy packets, because of which it makes the electrons come out of the metal surface. Okay, like I told you in a apple tree example, like if we throw some energy on the tree, apple gets detached. Similarly, if we throw some energy packets on the metal surface, the electrons come out. So Einstein said that light must be made up of energy packets. Okay, and then he named that energy packets as photon. Okay, now the question arises, photon is a particle. Okay, we know that photon is a particle, of course. Now the question arises that Einstein says that light is made up of particle, but Thomas Young proved that light behaves like a wave. So now the question is light a particle or a wave? So at this point of time, we do not have any answer. So then scientists again performed the double slit experiment, but this time they made some changes in the experiment. What they did that they installed some sensors or detectors on the observer. Okay, when they sorry sensors on the observer, they again got a wave-like effect on the observer screen. Okay, but then they installed some sensors or they installed some sensors on the slits. Okay, I do not have diagram right now of the double slit experiment as I have shown you, but they installed some sensors on the slit, and then they noticed that they get this type of projection on the observer screen. See the particles of light coming from one slit and the particle of light coming from second slit. Okay, so from this conclusion or this result, the scientists proved that light cares about being observed. Okay, what does this statement means? This statement means that light means if we observe light, it will behave differently, and if we do not observe light, it will behave differently. Okay, but means light has a dual nature. Okay, if we observe it, if we observe the nature of the light, or if we observe what we can say performance of a light, it will behave differently. But if we do not observe and let light perform anything which it needs, it will behave differently. So this is it for today's video. If you like this video, please leave a comment and like the video and subscribe. We will meet again in the light mystery part 2. Thank you everyone.